Welcome back. In the asset intelligence framework, our focus is often on the high-tech layers, sensors, advanced analytics, and complex financial modeling. But today, we are returning to the bedrock of operational excellence. We are talking about the 8 types of waste. A common misconception in the industry is that waste only refers to the physical scrap in a bin or visible oil spills on the floor. In reality, waste is any activity that consumes resources, time, capital, or energy, without adding a single cent of value to the end product or the customer. One of the central pillars of the AIF is this: you cannot effectively automate or optimize a wasteful process. Attempting to apply advanced intelligence to a disorganized, friction-filled operation only results in making that waste more expensive to manage. Our objective today is to identify the hidden friction on your floor and establish a clinical process for deleting it before a single dollar is spent on optimization. To categorize and target waste effectively, we use the downtime acronym. Let's examine how these 8 categories impact a high-stake manufacturing or processing environment through the lens of asset management. Defects. This extends far beyond the faulty product. It includes the forced deterioration caused by rework. Every time a machine must run a second pass to correct a specification error, the physical wear on the asset is doubled for zero additional profit. Overproduction. Manufacturing more than the immediate plan requires. This is perhaps the most critical inefficiency because it makes other problems. It ties up cash in inventory, and more importantly, it robs the maintenance team of the necessary windows to perform precision reliability tasks. Waiting. This is the most visible friction in the plant. It occurs when technicians wait for permits, when operators wait for materials, or when a production line sits idle during an avoidable repair. Every minute of waiting is a direct hit to the ROI of the facility. Non-utilized talent. This occurs when highly skilled staff are assigned to low-value tasks. Having a senior engineer spend hours on manual data entry or chasing spare parts instead of solving fundamental physics problems is a significant waste of human intelligence. The remaining 4 wastes are often built into the physical layout or the standard operating procedures of the plant, making them harder to perceive without a critical eye. Transportation. The unnecessary movement of materials between different sections of the facility. Each move increases the risk of damage, requires specialized equipment, and consumes labor hours that could be used for value-add activities. Inventory. Excess spare parts or raw materials sitting in a warehouse. It is common to find millions of dollars in ghost inventory parts held for assets that were decommissioned years ago. This is stagnant capital that should be deployed elsewhere in the business. Motion. Unlike transportation, motion refers to the human physics of the task. It is the time a mechanic spends walking back and forth to a tool crib or a workshop because the necessary equipment wasn't prepared in a point-of-use job kit. Extra processing. This is adding complexity where the physics demands simplicity. It includes over-maintaining an asset because of a rigid calendar or using a high-spec, high-cost machine for a task that a simpler asset could perform with the same result. In the asset intelligence framework, application follows a strict order of operations. Simplify, then optimize. Before you even consider installing a sensor to track waiting time or motion waste, the first question must always be, why does this requirement exist? If a delay is caused by an outdated approval process or a redundant safety check that doesn't actually mitigate risk, the solution is to delete the process, not monitor it. If motion waste was caused by a poor workshop layout, you move the tools to the machine. The AIF prioritizes removing the requirement for a wasteful activity over managing that activity through software. Only once a process is lean and stripped of physical friction do we apply the layers of predictive intelligence and automation. Consider a model case in a large-scale processing plant. The facility was struggling with a high mean time to repair on their primary centrifugal pumps. It was taking an average of 8 hours to complete a standard seal swap and alignment. By tracking the technician's movement, we discovered that 3 out of those 8 hours were spent purely on walking, back to the office for permits, to the stall for gaskets, and back to the workshop for specialized pullers. The waste, a combination of motion, waiting, and transportation. The fix, rather than purchasing faster tools or hiring more staff, the plant implemented AIF shadow boards and point-of-use job kits located directly at the pump stations. The numbers. The MTTR dropped from 8 hours to 4.5 hours. In an environment where downtime costs $10,000 per hour, saving 3.5 hours per event over 10 events a year resulted in $350,000 of recovered production time. Your homework for today. Perform what we call a Gemba walk. Physically walk the floor, but don't look at the machines. Look at the people. Are they waiting? Are they walking? Are they searching for tools or information? Identify one specific step that causes one of the 8 wastes and delete it. With the physical flow cleaned up, we are ready to address the friction you cannot see. In the next session, we discuss the 9th waste, information latency. I'll see you there.